All right, let's get right into it. We often think the future of AI is all about building bigger and more complex systems, right? Just keep adding more layers, more agents, more everything. But what if that entire approach is just completely wrong? What if the real breakthrough comes from thinking smaller, but a whole lot smarter?
Well, researchers have been noticing this really surprising trend. These absolutely massive, super complicated AI systems, the ones designed for maximum power, are frequently getting outsmarted by much, much simpler approaches. And honestly, this is a real head-scratcher for the entire field. So, on one side, you've got these huge multi-agent systems, or MAS for short. The best way to think about it is like a whole company of specialized AI workers. Each one has a different job, and they're all coordinated through these really elaborate workflows. But then on the other side, you have a much simpler method called chain of thought. This is more like a single expert, just thinking through a problem one deliberate step at a time. In this, chain of thought, or COT, is the surprisingly powerful underdog in this fight. It's not fancy, but it's an incredibly effective way to get an AI to just slow down and actually think before it gives an answer. It breaks a problem down into a logical sequence. Kind of like we do. And this isn't just a hunch. The research shows, plain as day, that this simple KOT method is consistently competitive with, and a lot of the time, better than, its complex cousins. This totally unexpected result made the researchers ask a really brilliant question. Instead of trying to build a better skyscraper by adding more floors, more elevators, and all these complicated architectural frameworks, what if the real secret was to first invent a fundamentally better, smarter brick? And that is the crucial point here, because that's exactly what they did. They created something they call the Agentic Reasoning Module, or ARM. Think of it as a supercharged reasoning brick. It takes a single step of a simple chain of thought and elevates it from just one sentence into this sophisticated, self-contained, agentic process. That just means it acts like a tiny independent agent with its own goals, all packed into one powerful super thought. So how do you find this smarter brick? Well, this might be the most brilliant part of all. It's not designed by a person. It's discovered through a process of evolution. It's this three-step loop you see here. First, they select a promising module. Then, in the expansion phase, an AI reviewer looks at how it did, and another AI designer actually mutates the code to try and make it better. Finally, they evaluate the new version. This loop just keeps repeating, automatically evolving smarter and more powerful reasoning modules. It's pretty amazing. Now, the idea is fantastic, right? But does it actually work in practice? Does focusing on the fundamental unit of thought really pay off in the end? Okay, let's get to the results and see how this new approach actually stacks up. Okay, and the results? They are wild. Just look at the performance jump here. You can see the complex automated systems, the MAS, clocking in at 37.2%. This simple chain of thought baseline actually squeaks by and beats them. But then look at the ARM approach. At 47.8%, it doesn't just edge out the competition, it dramatically outperforms them. That is a nearly 10-point leap in average performance. That's huge. And this holds true when you drill down into these specific, incredibly difficult benchmarks. We're not talking about your average test here. We are talking about competition-level math and graduate-level science questions. And as this table shows, the ARM-based systems consistently take the top spot, proving their power on some of the toughest AI tests ever designed. So what's the big picture here? What should you take away from all this? Well, first, the ARM approach delivers just flat-out superior performance. Second, it's way more generalizable. The same smart brick works across different AI models and tasks without any custom tuning. And most importantly, this points to a whole new way of thinking about AI development. We're shifting focus away from building these elaborate, fragile systems and toward discovering powerful, reusable units of thought. And the paper really hammers this home with their conclusion. The secret to more advanced AI isn't necessarily bigger, more complex orchestration. The real key to progress is improving the fundamental reasoning process, step by granular step. And that leaves us with a final, provocative thought to chew on. For so long, we've been obsessed with scale, with building these ever larger digital brains, that maybe, just maybe, the true path to more capable, more general artificial intelligence isn't about building a bigger brain at all, but about perfecting the very nature of a single powerful thought.